As we have seen the basics required to understand this program, let's dive in this program and understand how it is written. So the first thing is a comment that we already know, which specifies its license specification. Then the compiler version is specified. Okay, so what is the meaning of this compiler version specification? It means that any compiler version, yeah, above or equal to 0.7.0 but less than 0.8.0. So if you see here, when it got auto compiled, it was using a compiler version 0.7.6. So that's actually acceptable. Now let's see where is our smart contract. So you can see the contract identifier over here, and our contract's name is symbol bank. So if you click on this curly brace, it will show its scope from line number 4 to 26. We can see our smart contract. So whatever else is written over here, it is encapsulated within this smart contract scope. Okay, so this is the entire smart contract scope. Let's see what are the things encapsulated. So we can already see a constructor over here. We can see a state variable. Then we can see functions. First function is deposit function, other function is withdraw function, and also another function view balance. Our purpose is to simulate a bank account which is operated by anybody. Okay, so anybody can actually update this contract or access this contract. We are just focusing only on the basics of Solidity. Okay, so how will you simulate a bank account? So we need to have a variable that holds the current bank balance, right? So that is the balance variable. And if you see here, it is defined as an unsigned integer 256. So regarding Solidity data types, we will get into that in another video. Then the access specified is public, so anybody can get the value of this balance variable. So apart from using any of these functions, the balance value is actually accessible outside the smart contract. That's the meaning of this public access specifier. Now, what does this constructor do? If you see this constructor, it is not parameterized, so it means that its logic is not dependent upon the argument pass. So there is no argument passing happening. But when this contract is deployed, this code is getting executed. So what is this code doing? It is actually altering or setting the value of balance, right? So the balance variable is set to the value 0. So the state variable is set to the value 0. Note that whatever variables we define within the scope of the contract, those are state variables, and it will be stored in the blockchain. So it actually takes up some gas for storage. Now, these are the functions we can deposit or add to this balance. We can remove some balance, then we can see the view balance. So note that apart from this view balance, this variable is directly accessible. That we'll see later. Okay. Now let's go to the logic of this function deposit. So where is this function scope? It is this one, right? So starting from here to line number 14. So what is the logic written? It is written that the balance plus equal to amount. So what is amount? The amount is the parameter passed to this deposit function. So it means that whoever is invoking this deposit function should give an unsigned integer 256 as input. So that input or that integer will be added to the existing state value of the balance. So the balance will be updated with this amount. Okay, that's the meaning of this deposit function. Now, what is the meaning of withdraw function? Withdraw function means whatever amount we are going to take, right, it should be subtracted from this balance. So again, it is parameterized with an amount. So whoever passes an amount to this withdraw function and calls it, what is the logic executing? So this is how you will specify if else in Solidity. Okay, it closely follows C syntax for that. So the initial logic given here is if the state balance is greater than or equal to amount. Okay, if you can subtract, if subtraction is possible, then do the subtraction and update the balance. So that is the logic of this withdraw function. So the withdraw function scope is this much. That means the logic should be written on this area. Now, what is view balance function? Not how this function is written. Okay, so if you see the above two functions, they don't return anything, right? It just does some alteration of the state variable balance. It is not returning anything. But the view balance purpose is to see the value of the balance, right? Or get the value of this balance state variable. So apart from this normal function definition, here it is written as returns. Okay, it means that this function returns a particular value. Okay, and here it is written as a view. View means it just does only read operation. So not much gas will be consumed for that. So this view balance will just read the contents of balance. It doesn't alter balance and return the balance value. Okay, so if you see this function signature, function keyword followed by the function's name, then the scope of the function, who all can call this function, and the particular nature of the function, that is view is written, then followed by the returns keyword that specify the return type of the function. So note that in Solidity, functions that return a value, their signature will be separate. It will be having the returns keyword followed by the return type of the value. Okay, so these are the major sections of our code. So once again, if you run through this, the major sections required is the pragma solidity section, which defines the compiler versions apt for this code. Then the contract scope, right? The starting and ending of the scope. That is the contract, that is keyword. It begins at 4 and ends at the line number 26. So entire logic you should write within these lines, including the state variable definition. Then you will have a state variable definitions part, which is accessible to all the functions of this contract, and selectively it may be accessible to other contracts also if you are using it as public. Then you may have an optional constructor if you want to initialize or do some operations during the contract deployment stage. Then you will have your normal functions. Then wherever some function returns a value to the caller, it should have the returns keyword and it should specify the return type also. So these are the major parts of our smart contract logic. Now let's see how we can run this smart contract and interact with it in the next video.